Hello. All right, so we'll just wait, see if anybody else wants to join, and then we'll do this. Mhm. All right, so we'll just start. All right, question one. We have a hair dryer. It's plugged into a standard outlet, 110 volts, and draws 35 amps of current. What is the power consumption and what is the resistance? So, all right, just like always, start. Just write down what you know. V equals 110. Our current is 35 amps. We're looking for power and resistance. To find power, we can use P equals I times V. So we end up with a power rating of 3,850 watts. Multiply the two together, I and V. And then to find resistance, we can use V equals IR, rearrange it, get R by itself. All right, so that'd be R equals V over I, and that gets you 3.14 ohms for question one. Okay. For question two, the biggest question I had was, what is the potential difference required to run the speaker? Potential difference and voltage are basically the same thing. So it was just asking for what is the voltage or what is V. I have number two already pre-done. We'll do the rest like as we go. So number two, here's what we knew. We knew it had 1,000 watts. That's how much power was required. And we knew the resistance was 8 ohms. And the glare is really bad. I and V, current and voltage is what we're not sure of. So to first find I, since we have P and R, we can use P equals I squared times R. All right, rearrange it. I is the square root of P over R. We plug everything in, we get 11.2 amps. That would be the voltage. Or sorry, that's the current. And then we can use Ohm's law, V equals IR. All right, we know I, we know R. We're looking for the potential difference, which is voltage. We get 11.2 times 8, or 89.6 volts. So that's question one and two. All right, the rest we'll do with pen. I think it shows up a little better. All right. So for question three, we have two different. Unplugged my computer. All right, for question three, we're given two different voltages. All right, so one of the voltage is 220, the other voltage is 110. All right, we're also given how much current it uses. It's 20 amps. So I for both is 20. And then we're trying to find out two things. What is the resistance for each R, and what would P be for each? Okay, so it start off like this. All right, we know our voltages. They both have the same current. All right, and we're looking for the resistance and the power rating. All right, so to find out R, we can do V equals IR and then rearrange it to get R. So R is V divided by I. And we can do that for both ones. And then we can do the same thing for P. All right, we can use P equals I times V. So those are the two equations that we would require for this. And then, all right, we can just solve. So the resistance for the 220 is 220 divided by 20. That's 11. All right, and then the power for that would be 220 times 20, and that's 4,400. And then we'll do the same thing. All right, the resistance for the other one is 5.5 ohms, and the power rating is going to be 2,200 watts. So those are the answers for number three, straight across, right? So the top line is everything for the 220 scenario, And the bottom line is for everything for the 110 volt scenario. Okay. Question 4. An electric fence delivers a shock of 10,000 volts. So we are given our potential difference, or 10,000 volts. The resistance of the human is 1,000 ohms. Okay. So the first part says, what is I? The second question says, the fence itself has a current of 5 amps. How much power is required to keep the fence running? So in part 2, V is still 10,000, but this time I is 5 amps, and we're looking for power. Okay. So here's the setup for number 4. That's what we'll start with. So first we'll find the current running through the person. We'll use V equals IR. All right. And then down here to find power, it's P equals IV. All right. So this top equation, we're going to have to rearrange it for I. So I is V over R. All right, which would be 10,000 divided by 1,000. That's going to give you 10 amps of current. And then for power, it's just I times V. And that's going to get you 50,000 watts. So 10 amps is the current running through the person, and 50,000 watts is the required amount of power to keep the electric fence moving. Okay. And question 5. And yes, I saw your guys' question number 5, and yeah, that is something that's a mistake from a very old question. So yes, 5 as it lays out is technically impossible because we haven't learned this yet, and I am 100. That's all on me. You have to convert energy with time to power, which we have not talked about yet, and that's okay. So don't worry about number 5 at all. You can't do anything with just I as it is. That's all on me. My bad for number 5. Okay, so when you fill out the form, if you fill out the form still, you can just leave it blank for number 5. All right, I'll also post a key with the same questions done as well, so you don't have to watch this video if you're watching it. For anybody that's on here, does anybody have any questions about 1 through 5? All right. Well, see you later, guys. I'll put this up here and stay safe, and I'll see you soon. Bye.